Yeah, so you have 5 plus 302 divided by 2 times 100. So it should be 307 divided by 2 times 100. Should get 15,350. Yeah, pretty easy, right? And the way you could do it, let me erase the board too. Sorry about that. If I do try pulling up Desmos, I think you can actually call it up over here. Functions. Yeah, there we go. So you can see n equals 1, 100. And what was the formula again? It was 2 plus 3 n. Well, hold on. Why was that for a slider? Doesn't make any sense.
It's giving us some kind of what ending.
There we go. It's being dumb. You got to put parentheses. Okay. No, actually, this is good. I'm actually glad this happened. Okay. It didn't like that, right? What do you think Desmos is doing right now? This is good. I'm actually glad this happened.
You can't put any adding two and it's confused.
Well, it's order of operations. It thinks you're doing this and then plus 3n. When you do it this way, is a 3n part of the sigma notation? How do you make it part of it? Yeah, so that's why it's freaking out. So that's actually interesting. I didn't know that. Okay, I learned something new today. So yeah, so just make sure you do that, and then it's going to do it correctly. So anyway, you have that option as well. I wonder if I type in sigma, does it know what to do with that? Summation. Oh, okay. If you type in sum, there you go. That's a shortcut as well. All right, learn anything today. Cool. All right. So you can totally do this in Desmos. I'm not going to do TA4 calculator because I think Desmos is better. So we're going to stick with that. All right. So we're good with that one. All right, let's keep moving. All right. All right, next up. A small business sells $20,000 worth of sports memorabilia during its first year. The owner of the business has set a goal of increasing annual sales by 15,000 each year for the next 19 years. Assuming that this goal is met, find the total sales, not the sales after 19 years or the 19th year, but the total sales, right? So during his first year, each year for 19 years. Little confusing the way this is worded. Oh, first 20 years. Okay, never mind. It's not confusing at all. Okay, so I should have read the rest of the fine print. Find the total sales during the first 20 years. Okay, cool. So what's your A1? 20,000, right? Okay, your A20 is going to be 20,000 plus 19 times 15,000. Does that make sense? Right, because you're applying the common difference 19 times. And of course, you're doing A1 plus A20 over 2. And then times how many terms? 20 terms, right? And you work it out, and I'm sure you guys can be fine calculating it. I don't see that being an issue at all. Um, Now, if you want to do this in Desmos, how would I express that in Desmos? So sum n equals 1, 20. What would be my formula? Yep, there we go. Yeah, because that's what's because when n is 1, you want 20,000 to be the first term, right? When n is 2, then you want 35,000 to be the next term, right? You have to n minus 1 because you're only applying the common difference 19 times, not 20 times. So you have to put n minus 1. If you put n, it's going to not like that, right? That's why we spent that time writing the formulas. So you do have to be mindful about that. Yeah. So hope that makes sense. So the answer should be 3.25 million. Let me erase all the other stuff before. Yeah, the more I think about it now, I think most likely when we have this test, definitely our quiz next week on regression, I'm letting you guys use Desmos. I'm totally fine with that. But yeah, the more I think about it, I'm really kind of feeling Desmos, especially if you're doing AP Stats next year or AP Calculus. Desmos is part of it, so yeah, maybe just throw these in the garbage. I don't know. So
You get Desmos on the AP exam.
you do? Yep, 100% you do. Yeah, because the Blue Book app is built into it and it locks everything else down. So, but Schoology is just kind of funky. So I need to talk to Kamo again. He told me what to do and I forgot. So I got to figure it out again. So anyhow, okay, let's keep moving. Okay, cool. Okay, geometric series. We kind of talked about this last time. Um, so if it's going to be a infinite series, you write like this. Um, A1 over 1 minus R. And that's an S, by the way. I'm going to do both. Yeah. Actually, I ran out of space. I'll do it down here. So to find any term, it's A1 times R to n minus 1 power. Because when you plug in 1, you want the first term, right? If you plug in 2, then you want to multiply R. You multiply R a certain number of times to get to the term you want. Now, for a finite, it would look like this. So depending on what n is, that's when you stop for a finite geometric series. And now for infinite geometric series, it will converge. I'm going to talk a little about what we'll do in there, after this. It will converge if R is between -1 and 1. Because if you think about it, infinite means goes on forever, right? And what if your R value is like 3? So if you have like 2, 6, 18, 54, then 60 goes on forever, right? But what if your R value is 1/2 and your first term is 10? You have 10, 5, 2.5, 1.5, 0.65, 0.3125, so forth. Ultimately, the terms will converge down to 0, right? So the sum would be something we can figure out if the R value is between -1 and 1. That's a discussion we'll have at a later time. Probably even after this. But infinite, but the reason why we get rid of the 1 minus R to the n, your R is tiny, right? Let's say R is like 1/2. And you raise it to a large exponent, because n's approaching infinity, right? What do you think is going to happen to this term here? If you have a fraction raised into a large exponent, it gets close to 0, right? Exactly. It's like a limit, right? So that's why you just get A1 over 1 minus R. That's where this comes from. The derivation of this, I should have done my research on. I don't remember how that's derived, so I'm not going to worry about it for now. I know there's a way I could do it, but I just want to just start going through the formulas right now and working this out. So anyhow, let's now talk about find the sum of these, right? I'll do A and B and have you guys do C and D. For A and B, um, what's your first term? What's your common ratio? And how many terms are we talking about here? If you think about it, if you can use your fingers, 1, 2, 4, 8, 16, 32, 64. Yeah, it's 8. Yeah. Or you could also just divide 128 by 1 and set it equal 2 to the n minus 1 power. You do that also, right? Because you're applying the common ratio a certain number of times after the first term. We're applying it 7 times, so you're gonna have 8 terms. Because 128 is 2 to the 7 power. So what does n have to make that true? Of course, 8. You can always look at it from that perspective. If I work that out, 1 minus 2 raised to the 8th power, divided by -1, you should get 255. Or you could do this. If I go to Desmos, 1 times 2 raised to the n minus 1. Why does not like that? God, so annoying. But the calculator is bad. Yep, we get 255. So hopefully that makes sense, right? That one. Yeah.
I don't know if it's on the right. Like,
This is just if you didn't know how to find the 8 part, that's what I did. So what I did was yeah, sorry, I went over that really fast. My apologies. I divide the last term by the first term, which is of course 128, and set it equal to the ratio raised to n minus 1 power. The reason why I did that, tells me how many terms I have instead of counting with my fingers, which you could do if you want. Like, let's look at part B, right? I mean, part B, it's pretty obvious how many terms I have for part B. 6 terms, right? But what if you didn't know that, right? If I divided this by the first term and last term, right? I get -3125. Now, what's my common ratio here? -5, actually. Now, if you think about it, the negatives actually drop out, so you can actually cancel out the negatives because -1 raised to n minus 1, you could actually pull it out. That's okay. It's not a problem if you do that. And 3125, if you were to mess around with your calculator a little bit, it's going to be 5 to the 5th power. So what's that going to equal? Make that true. 6, right? I mean, obviously, just count it. You don't have to do what I just did, but that's what I was doing to help you determine what n is. So, then you just calculate it, right? You just do 2 times 1 minus -5 raised to the 6th power over 1 minus -5. Again, you can just add it using, by hand, right? It's not that hard. And if because the common ratio to go from the first to the second. Whenever the terms are alternating, you're gonna have a negative as a ratio, right? So if I do -5 raised to the 6th power, 1 minus that number, divide by 6, and times 2, you should get -5208. Okay, go ahead and try um, C and D. Actually, we'll just talk about C. We'll talk about what do you think the dot 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 means at the end? It's infinite, right? What's your first term? And you're doing a 1 minus r, but the problem is that this only is true. This only works if r is between what and what? Non-inclusive. Obviously, our ratio is what here? Yes, it's not going to work for us. This won't work. So it can't be determined.
Why would it?
Your ratio is not between -1 and 1. It has to be less than 1 or sorry, less than or greater than negative, but not non-inclusive. What's the ratio here? It's -1 spot on. That's why it can't work. Yep. So yeah, we just can't do it. So because it could be 0 sometimes, it could be -3. Or sorry, 3. Like we don't know. It alternates between 3 or 0, so we just don't know. Um,
But how is it alternating between 2 and 0?
because right now, if I stop right now, it'd be 0, right? If I had another term, it's gonna be 3. Yeah. So anyway, let's move on to D. Go and try D now. So figure out, well, A1's pretty obvious. It's 18. What's your ratio here? But it's finite. So you need to figure out what N is, and then do the formula. And it's probably going to do it by hand just so you understand how it works. But I'm totally cool if you use Desmos. So if you want to use Desmos, totally fine. But you have to figure out how many terms you have, right? That is important. How am I going to do that? How do I find how many terms I got? Divide what by what? Yeah, so you do the last one divided by the first one, which would be -2 or 27. -1 over. And what's my ratio again? So -1/3 raised to n-1 power equals that. Does that make sense? How am I doing that? Because you're doing a sub n or a sub 1, right? And what does a sub n equal again? Equals that, right? Do you guys see that connection now? Maybe I didn't make that clear. Because you're comparing the last term with the first term, so it has to be r raised to n-1 power. Has to be. And that's what I'm doing. And the negatives you don't have to worry about. They could drop out. How many times do you have to raise 3 to get to 243? 5. Good. So that's -1/3 raised to the 5th power. -1/3 raised to n-1. What's that going to equal, guys? Okay, let's work out the sum. But once you know the explicit rule, like, oh, 18 times -1/3 raised to n-1 power, you could put in sigma notation and you know what n is. If I do it this way, let's see what I got. 1 minus -1/3 raised to the 6th power times 18 divided by 4/3. Comes out kind of nasty. 13.481, I think, if I'm not mistaken. Or I could do this. I know n is 6. I know my first term is 18. I know that's -1/3. There we go. I get the same thing. 13.481. Okay, cool. So there's a lot of the nuts and bolts, right? A lot of the standard stuff. Any questions? All right, let's keep moving. You guys doing great. All right. Um, okay, I kind of got us ahead a little bit. There you go. That's a sum. Find the sum of each of these. The derivation, I don't feel like doing the derivation today. I should have researched this, my fault. Actually, I think it's not too bad. Maybe it might come to me in a moment. Go and try parts A and B. Actually, try using the formula again. If you want to punch in Desmos, I mean, you can. but I bet for you guys to try using the formula. Uh, what's your first term for part A? What's your ratio? What's your n? By the way, what if I did I equals 2? What's your n now? We go from I equals 2 to 10. That'd be 9 terms, right? That'd be kind of sneaky. Um, and your first term is not going to be 2 in this case, right? Because you're plugging 2. But anyhow, not sure I'll be that cruel. A1 is what's A1 here for part B? Nope. Careful. Hey, pick him, yeah, say because you got to look at what the formula, right? It says I minus 1 for A, but not true for that. So that's a little sneaky as well. R is 1/2, N is 10. Can work those out. Actually, I can do the derivation for you guys. We'll do it in a moment. It's not a ter obvious derivation, but it's okay. What do you guys get for part A? Okay. Yeah, because you have 2 times 1 minus -1/4 raised to 10 power. And
That's the zero. This is the zero.
yeah, it's essentially 1.6. By the way, it's almost like an infinite series because if you did 2 over 1 minus -1/4, because that's a really small number, right? -1/4 raised to 10 power, it's super tiny. So you're doing 2 or 5/4, which is going to be 8/5, which is, yeah. So you're right, Anna. It's close to 1.6. And in here, 8, 1 minus 1/2 raised to 10 power, or 1 minus 1/2. Do you guys do something close to 16? Was that? Yeah, I'll just say it's close up to 16. So, okay, cool. Now, actually, the derivation, I did cheat. I looked it up. Let's talk about the derivation here. So we know that Sn is this, right? It's A1 plus A1R plus dot 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 A1R raised to n minus 1 power. Okay, so that makes sense so far, right? That's what the sum of a geometric series is. Now, what if I did this? What if I did -R? Let me close the door too. Now, what if I did that? That's going to be negative A1R, negative, and let me line it up also. Um, minus A1R to second minus dot 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 A1R to the n power. So what you're doing is you're multiplying each of these by R, right? Sorry, by negative R. Now, if I subtract these two, if I combine these two equations, right, I would get this. Sn minus R times Sn equals, what's going to happen here? Cancel. A whole bunch of things will cancel. What are you stuck with? You're stuck with that, right? If you factor out Sn, you get 1 minus R. Factor A1, you have 1 minus R to the n power. What does Sn equal? So it's kind of nifty way that's how it's derived, in case you're curious. I'll give that to you. Don't worry about it. So, but that's how the derivation comes about. So you take what Sn is, which makes sense. The first term plus all the other terms multiplied by R, right? You stop at R raised to n minus 1. But what if you took that formula and multiplied by negative R? Then the terms change. You have negative A1R as your first term, negative A1R squared as your second term, so forth, and take a negative A1R to the n. If you combine those equations and then do some nifty factoring and then get Sn by itself, voila, you get the formula. So that's where the formula comes from. All right, let's keep on moving. Okay, so let's talk about example 6. Okay, now these are kind of problems I really like, right? This is where things get really fun. You told it's geometric, right? So you're going from A2 to A5. So if the second term is 4, you don't know the third, you don't know the fourth, the fifth term is 32. How many times are you going from the second to the fifth? How many times do you have to multiply R? 3 times. So 32 over 4 equals R cubed. What's R going to equal? R cubed is 8. So R is 2. So it means you're going to get 8, 16, and 2 as the first term. So again, just using some logic. I'm not getting too formulaic here, just use some logic. Now you're told the sum equals this crazy big number, right? So 8,388,606 equals, the first term is what again? 1 minus what's my common ratio? So 2 raised to the n power over 1 minus 2. Okay, how am I going to solve for n? What do I do to solve for n? You're going to use logs, yeah. So we know the bottom is negative 1. And then divide that by 2. That's be 4169. Sorry, negative 4169. Sorry. Hold on a sec. I didn't get rid of any negatives. That's negative 1. I multiplied both sides by negative 1.
Oh, okay.
That's all I did. Yeah. Does that make sense? How I got negative on the other side? Yeah, because I have because then that becomes negative 1, right? I multiply both sides by negative 1. Okay. Okay, so yeah, so sorry, that's 41 million. My bad. 41 million. Wait. No, divide by 2. Wait. Ah, I punched in wrong. That's my problem. It's like, well, that makes no sense. Yeah. So 4 million, I was right. Negative 4,194,303 equals 1 minus 2 to the n power. Then you got to subtract 1. So you get negative 4,194,304. Now, is a negative being risen to the n power on the right side, or just two? Just two. So it's PEMDAS, right? So you can drop off the negatives. The negatives will drop off. It's like dividing by -1. And then how would you solve for n? Log base 2. I know we haven't really talked much about logs, but you guys kind of need to know it. If we need to do a log review, we could. Um, Alpha window, log base 2 of that number. Should come out clean because you should have a whole number of terms. It would be 22. Yep. Okay. Now, that's the work you could show. How can we use Desmos? How can we leverage Desmos to help us get this answer without really doing all this algebra? Kind of. So let's actually and actually I don't know. I'm actually taking a leap of faith. I think I know what I'm doing. Let's find out. I don't know. Let's see. So we know sigma notation, right? Let's try that. Let's see what happens. Okay. So let me clear a screen. So I know I don't know how many terms are, right? So I'll call it n. I'll say y equals that. Or actually, let's give it an arbitrary letter. We'll call it x. And the first term was 2, right? And my common ratio was 2 again, raised to n minus 1. And you can see it's all these like discrete values, right? And I want that to intersect with what? 8388 606. That made no sense. Sorry. That was so dumb. We'll go 0 to 30. Just kind of estimate that. I meant to do for y. 8 million, 9 million.
Why does it do all these stuff?
I don't know. I don't know what's going on here. Hold on. Did I just do something really? Again, I don't know what I'm doing. I'm just seeing if this could potentially work. Um, hmm. Did I put something wrong in? 2 to 4.
Slider.
No, because I want y to equal that.
Doesn't that just become 2 to the n? It's 2 to the n. Okay.
Ah, that's it. Wait, no, no. 8388 606.
Does it have to be X under the sigma? Yeah.
Maybe. I'm just taking it. I don't know. I'll figure it out. So, I don't know. It doesn't like, I don't know. Okay, I'll think about it later. I was trying to get fancy here on you guys. Let's keep moving. All right. Okay, let's look at example 7. Okay, go and read that first yourself so you understand what's happening, and then we're gonna work this out. Okay, so let's say so you graduate for like well, some of the juniors, like you're gonna be you're probably 17 right now, right? So 5 years, you'll be 22, right? So you finish college, you just started a job, you don't have any money, but after a year you get some money, right? And you figure, okay, and actually before April 15th is when you can actually contribute to your own retirement plan. You can do an individual retirement account, IRA, right? Um, so after 1 year, you say I put 20 grand, and that 20 grand grows for some time. And essentially what's happening is that you're going to retire by the age of 62, right? So you're going to do this, or actually, let's just say you retire at age 63, just to make the math simple. Um, or you put money at when you're 62 and then you wait another year, then you're done. So here's, if you think about it, this is actually going to follow a geo series. This does actually follow a geo series. Here's the reason why. So right now it's year 2026, right? So let's say I'll use one of the juniors in here. Um, so in 2031, you graduate college, right? You start working. In 2032, you put your first $20,000, right? And that money's going to sit there for 40 years, let's say. So by the time you get to 20 72, actually, we'll say 20 73. Yeah, 2073. I'm gonna be pretty, maybe I'm still alive, hopefully. Uh, if you think about it, you're doing 20,000, 1.08. So to go from 2032 to 2073, how many times are you applying this common ratio? 40 times, right? You're applying it 40 times. And why am I multiplying by 1.08, by the way? It grows by 8%. So after 1 year, you take your 20 grand, you multiply by 8%, which is 0.08, but you add it on to the 20 grand, right? So that's why it's 20,000 times 1.08. But because that money, that the initial 20 grand that you put into your retirement account, so by 2033, if you think about it, how much is that 20 grand worth? Whatever 8% of 20,000 is, which is 1,600, right? And you're doing this to go from that to 2073, you have to apply this 39 more times, right? So that's why it's going to be raised to the 40 power. Okay, so that's when you retire in the year 2073. Fine. Um, so that 20,000 gets compounded 40 times at a rate of 8%, which is pretty generous. Now, you said I put another $20,000 in, right? In 2033. So now you've worked for a year. You put 20,000 in, you made some interest, cool. Now you said I put another 20,000. Now, the second time you put 20,000, how many times does that get compounded? 39 times, exactly. Now, when you get close to your age of retirement, like right before you retire, you put one more $20,000, that will see it another 8%, right? So if you think about it, you're adding up all these totals, right? You're adding up you're putting $20,000 repeatedly every year, But some years get more compound than other years, right? Depending on when you put the money in. It's following a geometric pattern, right? Because there is a common ratio here, right? What's a common ratio between each consecutive term? Oh, geez, let me get my plug. What's the common ratio in consecutive terms? 1.08, exactly. It's 1.08. So really, you can just do this, and you'll be pleasantly surprised how much money you'll have if you actually follow this plan. So assume your first term is 20,000. We'll assume n is 40, and your r is 1.08. And actually, I'll set up a sigma notation. We'll do n equals 1. And we'll do to four. We'll do it to 41. You go an extra year. We'll do it to 41, and you're going to do 20,000 1.08 raised to n minus 1 power. We're going to punch in Desmos to see what you get. Yeah, I got a little political there, so don't mind that. Yeah, I can get away with some. We're in the Bay Area. So, okay. So sum n equals 1, 41, 20,000, 1.08. That's usually the rate of return of the S&P 500. N minus 1. Oh, hold on. There you go. You wind up making about $5.6 million. So it's a really, really wise choice to invest your money in this manner. Now, 20,000, mind you, you'd have to make sure you can sock away that much. I mean, you have to have a pretty good salary. It's about 1,600 a month. Um, yeah, some people can't afford to do that, but if you could, and you're mindful, you don't overspend, you buy a car within your means, you don't, you live modestly, you could totally do this. Yeah. Mhm. Well, see, that's the thing. We don't know what 40 years is going to look like, right? Right now, like if someone's in their like their mid 60s or late 60s and they retired, um, you probably maybe you if you're by yourself or you and your partner or spouse, probably need maybe living in the Bay Area, probably about 200,000 to live comfortably. Assuming your house is paid off, you don't have a mortgage, you paid off your mortgage, all that stuff, right? Yeah, if you want to travel and be generous with your grandchildren or whatever, probably about 200,000. Now, if you think about it, if you're like 65 years old, 20 times 200,000 times 25 is about $5 million. So you're hoping you could live up to 90. You live past 90, you may run out of money. Then you might be in trouble. But here's the other thing is that this money, you're only withdrawing about 200,000 every year, right? So you can still keep the money in the account and the money can still grow as time. So that's another type of annuity we could talk about later on if we have time to do that. But you could probably live up to 100 with this money. Now, in 40 years with inflation, you might need more. True. And you might be on Medicare by that time. Right. So this is kind of a cool thing because you're getting into personal finance, right? It's kind of neat. Yeah, but Social Security doesn't pay much. Um, that's because if I'm starting at the age of 22, I'm gonna end at 63. But at one,
You want to retire?
yeah, that because I wanted to do this about four. I wanted the compound to happen 40 times. But if I did this, you get that. But you can see, does it make sense to work an extra year? Heck yeah, right? Because you work an extra year, you're still growing more money before you start taking withdrawals from it. Because see right here, that's like 5.18 million. That's 5.6 million. That's an extra $420,000.
You could also stop working, just let the money sitting there for another year, but you take it out and risk.
You could, but it's nice to contribute if you can. Yeah, if you could. Mhm.
Why did 41 for the phone?
Yeah, I think I did 41 because I wanted the initial amount to compound 40 times. I think that's why.
Okay.
Because this amount would have been 20,000. I think that's the reason why I did that. I wanted to compound 40 times. But regardless, I just want to just kind of show you how that looks. Now, coming, Oh, I'm asking a different question. I'm not asking on a test. I just like talking about finance. That's all. No, this is not a test question. You'll see the test question in a moment. All right, example 8. Now, this is just very simple. What if you just took 20,000 and put it underneath your sofa mat, your sofa cushions or your bed mattress, right? Or put it in the closet, put it in a safe, right? Like you're a drug dealer. I don't know. 20,000 times 40 is only $800,000. So if you really just despise banks or don't trust banks or don't trust the stock market or whatever, well, that's kind of dumb. Tr you should be fine trusting the banks. I mean, yes, there was a time in our U.S. history in 2008, for those who don't know, the economy collapsed because of the housing market, but for the most part, you're fine. You live long enough, you ride out 3 or 4 economic cycles and a lot of different presidents. We have some good, some bad presidents. You'll be fine. Unless this current one really destroys our world, but I'll stop there. Okay, so 800,000. So that doesn't make sense, right? You're much better off investing your money. All right, let's keep moving. Okay, I don't know if I really care so much about. Hold on, I'm gonna jump around a little bit here. Actually, let's go through these problems here. We're just gonna jump straight to these examples. These will be fast. Okay, arithmetic sequences. Um, so if you're asked about the first 3 terms, that's pretty easy. What would the first 3 terms be for this?
7.
7, 11, and 15. Or here, this would be 2, -3, and -8. Pretty easy, right? So essentially what you're doing is you're doing n-1 times d. So to find the nth term, it's going to be a1 plus n-1 times d. So for example 2, find the formula for the nth term, whose common difference is 3 and the first term is 2. Okay, well a sub n will be 2 plus 3 parentheses n-1. And we're at the first 3 terms. Well, if I plug in 1, that should be 2. And you're adding 3, so it's 5 and 8. Now we already know the nth term, which is right here. That's the nth term. So we're okay with that? All right, so moving right along. Go ahead and figure out example 3. Then we'll move on to more examples after that. Actually, while we're at it, go try example 4 also. So do examples 3 and 4. I'm going to nix example 5 because I don't think we need that for the problems we're going to be working on. Let's look at the homework here.
I think it's
No, I'll briefly talk about example 5. It's kind of good to talk about. Just do example 3 and 4. Okay, what do you get for the common difference? Yeah, and what you could do is subtract the 2 terms, but to go from the 4th term to the 13th term, you have to apply the common difference 9 times. So you're going to the 5th, the 6th, the 7th, the 8th, the 9th, the 10th, the 11th, 12th, the 13th, right? So you're adding the common difference 9 times. So it's 5. So now if I want to write out so 5, 6, 7, 8, 9, 10, 11, 12, 13, third, second, first. So 15, 10, and 5, and this better work or I'm going to be mad at myself. 35, 40, 45, 50, 55, 60, 65. Cool. Let's look at example 4. Find the 20th term. The first terms are 2 and 9. What's the common difference here?
7.
And you're going to do 2 plus 20 minus 1 times 7. Because after the first term, you have to apply the common difference 19 times to get to the 20th term, right? Even though you're doing 20 terms, 20th minus first term is 19 terms. Like 13th minus fourth term is 9 terms, right? So 19 times 7 plus 2, you should get 135.
Going back to example 3, how do you know that there's,
9.
no, like, how do you know to not? Because normally there's like, it's plus something, you know what I mean, like, it's like, you multiply by the total difference and you add something, but you don't know the first term, so you just like.
So what I did was I looked at the terms I was given, the 4th and 13th terms, and I kind of figured out, well, to get from the 4th term to the 13th term, how many times I have to how many jumps do I have to do? How many times I have to apply the common difference to get from the 4th term to the 13th term? If I kind of sort of just let's walk up to the board here. So we have this, and we have this, right? So if I think about it, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why I think we're assuming the term limit and divide by 9. Because 9 times the common difference is going to be 6 5 minus 1. So another way to think about it actually might be better if you think like this. 9 times the common difference equals the 13th term minus the 4th term. Because you have to jump 9 times to get there. So I hope that makes sense. Okay, and then for example 4, we get 135. We're fine with that. All right, we'll keep moving. For example 5, let me just explain what that means, because it's more of a notation thing than anything else. When k is 2, sorry, when k is 1, my apologies. When k is 1, you're saying that a2 equals a1 minus 2. Right? If I put a 1 here and 1 here, I get that. What's a1? And 3 minus 2, of course, is 1. So what's a3 going to equal, guys? a2 minus 2. So we call this a recursive sequence because it's recurring. It relies on the previous output to be the input for the next step. If that makes sense. So a2 is 1, so I do 1 minus 2, I get -1, right? It's pretty obvious. What are we doing here repeatedly? Subtracting 2. So it's not that hard.
You can't just make a pattern. It's like you subtract 2.
Right, but sometimes you get some that are really weird, and you have to kind of calculate them. Yeah, this is pretty obvious. It's a common difference. It's pretty obvious. And so -2 is your common difference. And the nth term is going to be the first term plus n minus 1 times -2. So that's called a recursive sequence, just so you know we see that notation. So I'll make sure, at least I just talked about it. It's nothing I really care too much about, but just good to have that discussion. Okay. Let's talk about geometric. Good question so far? We good? All right. For geometric, what's the pattern for geometric? You're multiplying, right? Common ratio. So determine if they're geometric. If they are, tell me what R is. Is A geometric? No, it's arithmetic. Because you're adding 2. Is B geometric?
Yes.
Yes. R equals 2. Is C geometric? And what do you multiply by? 1/3. There you go. Okay. So it has to be exponential in nature, right? See, this is linear. That's exponential. So in general, we could just say, I'm just gonna tell you the formula. I mean, we already talked about it, so it's should be pretty fast. That's the formula for a geometric sequence. Find any term you want, right? You do that. So example 7 says write out the first 4 terms. The first one is -1, converse is -2. Example 8 asks to find the formula, find the 9th term. Example 9 is telling you to do all that stuff. So work out example 7, 8, 9. And then we'll talk about infinite geometric series, and we'll be all done. And then we could really focus on the crazy problems next week.
It's not bad. No,
Oh, you don't?
I didn't get any of it.
Wait, were you provided with all this?
Yeah, I will. Oh yeah, sure.
Like objective, like
Before you forget.
Wait, that's really.
I might have forgotten.
It takes us number 8, are we using the 5 hours? Like.
Rate, what about the rate?
5 is the wrong number.
Yes, correct. Right.
Wait, that was second. You review the broken columns. Really? Yeah. No, mine is no, I can't handle any of this stuff. It definitely is worse than me. I think it's hot Cheetos. You can't eat hot Cheetos? Yeah. I need water.
Wait, yeah, I can't eat hot Cheetos. I eat like 5 and then I'm done.
I feel like you feed it too, so. Like.
Is it serious?
You just ask. Should I
know?
Just do it. It's okay.
But Julie, what is the difference between a sequence and a series?
Sequence is a list of numbers, series when you add them up. That's the difference. Yeah, I should have been clear about that. My apologies. Sequence is simply a list, series when you add them up. And we'll actually delineate that more clearly in our unit afterwards. Because we will talk about find the limits and find having series converge and things like that. Okay. So for this one here, for the first 4 terms, -1, 2, -4, and 8. So the nth term is going to be -1 times -2 raised to the n-1 power. Here your ratio is 3. So 9th term is going to be 5 times 3 raised to the 8th power, wherever that is, which is 32,805. And the nth term is going to be an equals 5, 3 raised to n-1 power. Here, your ratio to figure that out, I think it's is it 1/2? Yeah, 1/2's your ratio. So to find the 14th term, you just divide this with this. And if you divide those together, and you're gonna set equal R to the 6th power, because you're doing A10 over A4, right? Wouldn't you guys agree that'd be R to the 6th power? Because you have to multiply R 6 times to go from the 4th term to the 10th term. 5, 6, 7, 8, 9, 10. And if you divide those together, you should get 1 out of 64 equals R to the 6th. That's why R is 1/2. So to find the 14th term, you're going to do the first term. So gosh, I go backwards. So if that's 125, 250, 500, 1,000. So 1,000 is your first term. And that's 2 raised to the 13th power. Oh, 1/2. My apologies. You are correct. So in that case, it'll be 1,000 over 8,192, or a super small number. You could write it like that. Good for you. Did he have something really spicy? Okay, good. Okay. All right. Now the last thing I want to talk about, let's not worry about the last page. I think you guys get the idea of what's happening here. We could always revisit it later. We already talked about this anyway with the common ratio. Okay, the homework. Uh, you might be a little discouraged. I don't know. We'll see how it goes. Let's talk about so I'm gonna have you guys do 1 through 8. There's 16 problems. I'm gonna have you do 1 through 8. Let's see how it goes. I have the answer key so you can check your work and reverse engineer it. 9 through 16 we'll do in class on Monday. And then I'll give you guys another packet that has even more challenging problems. But let's take a 1. Take a look at 1 real fast. We got a few minutes here. Let's take a look at 1. All right. What is that first equation telling you? For number 1.
Term 5 and term 7.
The 5th term plus 7th term adds up to 1,500. What does the second equation tell you?
11.
Was the 13th term equals 187,500. Now, this is geometric, right? You have 4 variables, T5, T7, T11, T13. You have 4 variables. How many equations you got?
2.
That's kind of a problem, right? So what do you think we need to do? Because you can't solve it right now the way it is. You have to do something.
Well, can you get more? Well,
Yeah, create more equations. 100%. I'm with you 100% with that. That's a brilliant idea. Would you guys agree with that? Because if you have T5 and T7, how many times multiply R? Twice. Would you agree with this? Okay. I'd agree with that. Okay. And you're asked to find all possible values for the first 3 terms. Okay. Also, while we're at it, isn't T11 just T5 times R to the 6th power? Or actually, let's do this. T11 is T5 times R to the 6th power. And that's T5 R to today's power, right? So if I do T5 plus T5 times R squared equals 1,500. Factor out T5. And then if I do this next one, T5 times R to the 6 plus T5 times R to the 8 equals 187,500. I can factor out T5 here and R6 while I'm at it. You guys agree with that? That 2 equations, 2 variables. Yeah, I'm not gonna do any more. Let's figure out the rest. But you could totally substitute, right? Because you could say, oh, well, I know what 1 plus R squared is gonna be. It's gonna be 1,500 over T5. I can substitute. Things will cancel out. I'll get my answer. I'm gonna let you guys figure out the rest. That's the kind of thinking I need you guys to do. I need you guys to get creative with the problem solving process. So try these out, see how it goes. If you get discouraged, don't worry. Please, please, please do not spend more than 40-ish minutes on this homework. If you spend 40-ish minutes, you're like, I give it, I can't do this. That's okay. That's totally fine. We're going to talk about these problems on Monday. So give it your best try, see what you can do, and then I'm going to help you guys on Monday. Next week is all about problem solving. All right. I got you guys the nuts and bolts. We came back from break. I'm just gonna ask you guys to work 1 through 8. Don't worry about it. We do have the quiz next week, by the way, on logistical regression. That should be pretty straightforward. But I'm gonna sign 1 through 8. Okay. All right.
I'll have that. Okay,
Logistic regression. Sounds Goldie.
I was like, am I gonna remember it? But I did.
Potentially